Good afternoon, everybody. So my name is Fred Rivard, and with Vincent Perrier, we will present you MicroEJ, the solution for embedded Java for small devices. So I'm the CEO of the company, and Vincent is the Chief Product Officer. So I will briefly go through the company, what we have done since 5 years, how many devices we have, and then we'll explain more in details what is MicroEJ, the platform, and why it's a benefit. It allows to have lots of benefits for the IoT market. So about MicroEJ. So we started the company MicroEJ 2000. The first fundraising, about 1 million, was in 2007. Then 2011, we did a 5 million fundraising. We currently have roughly 1 million devices running our technology and a backlog of 20 million. We cover roughly every market that have or involve microcontrollers. So it's appliances, white goods, industrials, telecommunication, meters, smart homes. So probably everything that can be tagged as smart something, smart market, and now IoT. So we are a fully independent company. We own all our IP. MicroEJ is a small engine that runs C and also Java code, and we are 35 people, and with well expertise in all what's called virtualization, compilation, and of course business model and what our customer cares about. So a few other references. So like you can say, it's quite wide. And it's worth mentioning that we have partnerships with ST, Renesas, Freescale, NXP, and all these silicon vendors provide our solution to the market. So that allows us to gain a customer like Bonk, TCL, Verizon, Orange, so high volume customers. Before we go deep into what the IoT market is for us and why MicroEJ is valuable for this market, I wanted to give you a brief technical overview of what's MicroEJ, the engine, and let's say the size, the footprint, and the speed. So basically, the engine is 30K of flash. So it's basically is available to run on any kind of microcontrollers. And in terms of libraries, we have numerical computation, GUI, sensors. So everything what you can find on, let's say, an Android-like platform, you can have it here on small microcontrollers. So I will do a small demo here. So it's a Cortex M4 on this board, and running at 100 megahertz. And I will reboot the application. So it runs several applications like a clock, like a stepper, fitness, music, weather, etc. And so the platform boots in less than 2 milliseconds, and it takes 40 more milliseconds to have all the application up and running. Yeah, so it goes quite fast. Compared to a Linux system, we boot in 50 milliseconds. Just to give you in terms of what can be done in terms of fluidity, so that's a watch. We can go back. Music, for example. I don't know if you see the small things running on the display. So we have 50 frames per second. Even though we have still lots of CPU power. Typical example is processing some kind of waves from an oscilloscope, etc. And so basically the technology is available for lots of embedded applications. So why we have done that? Basically, we are in this digital revolution where we see a lot of devices in terms of how many devices that need to be programmed. Here you have how many humans on the Earth, and here's the numbers of devices. So you can see the huge growth rate, meaning that there are lots of devices to program. In most human activities are impacted. So it's healthcare, industrial, smart home. So any kind of basically activities around the a human. So in terms of volumes, lots of people are talking, okay, IoT, embedded devices are lots of billions of devices. So here are the true figures. And here you've got what we call the microcontrollers figures. This is the amount of devices that will be produced by, let's say, the whole community. Roughly 40 billion devices. And within these 40 billion devices, there's a kind of devices that are economic, that needs to be quite cheap, with an average selling price of $3. And to target this $3 chip, you need to have a very small, compact platform, and that's what MicroEJ provides you. So I will let Vincent do the...
It's for the recording. Okay. All right, thank you, Fred. So I'm Vincent, and I'll talk about the challenge in IoT, more precisely in regards to what Eclipse is providing, and later on I will explain you how we can help achieve this challenge with MicroEJ. So, really, the idea, if you look at the distribution of devices, you will find, I would say, the well-known Android, Linux, and Apple devices representing approximately 25% of devices shipped. And then you have this whole 75%, which is probably representing what can be called the IoT. So that's the non-smartphone tablet devices. You may think of those as sub-gig things, sub-gigahertz, sub-gigabyte things. This means that they have low-cost, low-end processors. They're not running at 1 gigahertz frequency, but running around 100, 200 megahertz frequency. They don't have gigabytes of flash or RAM. They could have megabytes of flash and RAM, all right? And obviously, so those platforms, the traditional platforms, Android, iOS, Linux, won't fit in those particular devices. Even though they have great benefits, why they have been successful in the market? Because they are providing great software tools and libraries and rich ecosystem. And also, really what made this possible is that any programmer could basically write an application for Apple or for Android or for Linux devices. Okay? But they have problems. So precisely those platforms that are well known in smartphone and tablet area cannot scale, cannot address the IoT market. We have to find something else. So what are the success criteria? If you look at IoT technical and economical environment, what are you looking at? In terms of time to market, you're talking about product cycles and development times that have to be really short and basically follow the internet pace, which is very fast, very short product cycles. So you have to adjust to this, so reduce the development time and make sure that you don't miss your product market, otherwise someone else will take the market than you. The business models, so the smartphones and the tablets, they have established new user experiences, new business models that everyone is familiar with. And you can expect that people with the IoT devices would like to find similar user experience. And the providers of those devices would probably leverage the same kind of services you have today on your smartphone and your tablets that are based on either application-driven services or also getting some data produced by the users of the devices and taking this to the cloud for data analytics and exploiting this data coming from edge devices on the internet. So in terms of technical aspects, in terms of the software complexity and portability, the software complexity is growing, obviously, because a device connecting to the internet is no longer this, I would say, simple embedded smart connected devices, but you have a full range of software that you have to integrate because you want to connect to the cloud and provide much richer user experience and services. So it's really about bridging the gap between what used to be the embedded and technologies and practices and methods coming from the cloud space. So namely, you can think about programming languages. So the embedded world, the small things that Fred was talking about, traditionally they have been running on C code, right? The cloud and the IT world are running probably more on Java. That's one first gap. The tools and the methods, agile methods, Eclipse IDEs, things like that have to be available for IoT devices. Virtualization has been really important progress factor for internet applications. So this is something also that has to come to those type of devices, as well as the capability to run multiple applications. Most of the embedded devices, like traditional and legacy embedded devices, are single application. They run one thing and only one thing. And most of them will run exactly the same code throughout their life. Now, you could have on-the-field software upgrade, but when it comes about running multiple applications and adjusting to the conditions, operating environments, then that's something different. And I was talking about all those standards and middleware and protocols that you have to support for IoT. It makes this very complicated. And about the hardware and the firmware scalability, so what made Android and iOS and Linux possible was a single platform. You have a PC, or you have an iPhone, or you have Android platforms, all right? Now, if you come to IoT or to the embedded space, it's fragmented, it's diverse. You have 10 silicon vendor providers. You have lots of combinations of operating systems, of compilers, of firmware, of protocol stacks, and all of those make millions of possible combinations, and you have to make sure that your software can run on all those million combinations. It makes your life as software developer very complicated. Okay, so if we look at what Eclipse is providing in terms of IoT deployment, first of all, that's it's open source software with, I would say, business-friendly license, which is very important. It's the IDE that everyone knows, Eclipse. Supporting the major programming languages, Java, C, C++, and JavaScript, which is also coming strong for programming the applications of IoT in the future. And then you have implementations of open IoT standards, providing communication protocols, device management frameworks, gateway server interfaces, and also building blocks for those services and framework for managing the devices for, again, communications and vertical solutions. So I'm listing here some the projects that you can find on IoT Eclipse website. So co-op with DTLS, smart M2M, MQTT, lightweight M2M implementations with the Eclipse project names, and OSGI Java framework and some other framework. I will just let you read that. But this is great. All of this is necessary for implementing IoT devices and deploying IoT devices, but to run all of those software stacks and framework, you need a scalable IoT platform for your deployments that can support this and can make sure that all this software is deployed across the variety of hardware and firmware that you can find in the IoT and embedded space. That's really the challenge. Okay. So let's see how we can address this, this challenge with the MicroEJ IoT solutions. So if we define what is MicroEJ on a board like this or on an IoT device or an embedded device, we call this an application platform. That's really all the software layer you need to run multiple applications in an efficient in terms of speed, in terms of memory, and secure way. When you have multiple applications, obviously you don't want that one application crashes the other or crashes the entire system. That's very important, okay? So Android is doing this very well, but for high-end systems, tablets, smartphones, and high-end microprocessors, they are costful. If you want to deploy billions of IoT devices, you cannot pay $10 for each microprocessor, right? You want to pay those prices around $1, $2, and those are no longer microprocessors. We call them microcontrollers, okay? Small, low power microcontrollers that we were talking about. And this is where MicroEJ fits in those sub-gig things with low-end microcontrollers. Now looking at how is built the MicroEJ application platform. So obviously it's running on the hardware. And then on top of this hardware, you have hardware-dependent software, which is usually provided by either the silicon vendor or by partners. So what is it? You have device drivers for driving the hardware from software. You have something called BSP, board support package, which is the bootloader and some other software, and including the drivers. And then you may or you may not have an operating system. Usually it's a real-time operating system, RTOS. And you have a set of libraries that can be a TCP/IP stack, that can be SSL stack, that can be a file system, something else, right? That's really the basis for starting to run software on this. And usually that's a C-level type of programming. And it's very diverse. There's nothing standard here. Every microcontroller, every vendor comes with its own set of stuff there. So our job is to provide something standardized on all this variety of hardware and firmware. So what do you find? You find, first of all, a C interface, so you can integrate this, and you can also integrate to your legacy code, because there's a lot of legacy in embedded. And then you will find a secure application engine. This is the virtualization layer that will make sure that all the applications running on your hardware are run in a safe, secure, and efficient way. You will have memory management, very important, to avoid the usual problems with C, with the malloc and freeze, and with the ROG pointers that are crashing the entire system. You don't have this, obviously, with Java-style memory management. Power management, those things either have to run on battery or on nothing. They will get the power source from the network sometimes, so they have to be very efficient on power. So that's why the power management building block is really, really important. Components management, that's the framework that provides this sandboxing, safe, multi-application environment for you. And then on top of this, that's really the core, that's really the engine. And on top of this, you have a set of libraries. You have I/O libraries to communicate with the hardware, potentially to interface with analog I/Os, because the controllers are usually controlling something, some motors or some sensors or actuators. You have a file system or some data format. If you want to store some data in XML or in JSON format, you will be able to do this. You have communication protocols. You have serial links. You have USBs. You have I2C, SPI, things like that. Then all the network and security layers for the internet, TCP/IP, UDP, HTTP, all the IoT middleware, CoAP, MQTT, and others. The numerical processing that Fred was talking about. When you have analog data, then maybe you want to do a FFT on it, or you want to do some matrix calculations. The GUI, if you have a screen, whether it's touch or non-touch, then you want to have very nice GUI, just like what we were showing here. So you have to get a very optimized GUI. And the store. So the store is the capability to basically download the apps from an application store, just like you do with your iPhone or with Android. And I will detail this later on. Okay. And then you can have the applications. And really, this is where we see that some of the value provided by Eclipse comes into play, because in our set of libraries, we have integrated building blocks from Eclipse projects, PAHO and Californian. And if you wanted to use other Java stuff provided by Eclipse, you could definitely do it at the application layer up there. Okay, so I was talking about those hardware and software foundation on top of which the MicroEJ application platform is built. So hardware foundation, we support various types of microcontroller architectures. The most famous and I would say delivered is ARM. So it can be Cortex-M or A architectures. Then we also support other architectures. And you would have vendors like ST, Freescale, Renesas, and XP talking about the most famous one. And then in terms of real-time operating system, BSP drivers, or libraries, native stacks, then you have those players there. Some of them are operating systems like ThreadX, FreeRTOS, VxWorks. Others are compilers like Kyle, CDT, GCC, IR. So all of this is basically what you have to deal with when you go to the IoT and embedded space. All right. And obviously the goal for you is not to rewrite your applications for every single combination of all of that you have here. That's why this unique application environment is really, really key. Okay. So now talking more detail about applications and application store for the IoT. So everyone is very, very familiar with the notion of marketplace or application store. You have your Android or you have your iPhone. You connect to the store, you get an application, you download it, you install it, and you have it on your device, and you can use it. Well, we provide exactly the same user experience and exactly the same capabilities for service providers for the IoT. So that means for those little tiny devices, okay? Because all of this is possible on iPhone and Android because they have gigahertz processors and gigabytes of flash and memory. But it's a very different story when you have megabytes of memory and megahertz single core microcontrollers, right? So it has to be very optimized. So that's pretty simple. Application designers, they create applications using our MicroEJ Studio, which is built on Eclipse. They write Java code for our MicroEJ API. They can build those applications for virtual devices that are the virtual images of the real hardware. They can run this on a simulator, or if they have an evaluation board, evaluation kit from hardware vendor, they can connect this to their PC and run their application there. Now, when they're happy with their application, they push it online to an application store, and they say, okay, this is application doing this and that's compatible with my microwave oven, with my washing machine, with my cars, this and that from this and this manufacturer. And the owner, the user of the device can get to the store and download the app and customize the software content of its device, right? So it's creating a whole IoT ecosystem. You no longer have an embedded device sitting here and doing something. Then you have application developers, you have service providers, you have end users, and all of them interact to make the user experience and the services delivered by those devices much more interesting in terms of value for the user and also business models. So MicroEJ is basically addressing 3 different types of profiles. I talked about the studio for application developers, the one creating the applications using Eclipse-based studio writing in Java. Then for building, bringing up the application platform on the hardware, you have an SDK for OEMs, the ones providing the devices. And for the application store, there will be one hosted by MicroEJ. But if OEMs or service providers, they want their own store, they will be able to instantiate their own store based on what we're providing. Okay. So really what we are promoting here at EclipseCon, it's the free MicroEJ Studio. So we announced it yesterday, so it's available for download for free. You go to store store.microej.com, you register, and you get an alpha version of the studio for trial. So you can create applications. You can create applications today for 2 first devices, evaluation kits from STMicroelectronics, F7 Disco board, and Synergy S7 kit from Renesas. So you can run this on our simulator on your PC. And if you buy one of those boards, they're not too expensive, right? Everyone knows about Raspberry and Arduino, but those boards, they sell from 50 to 100 euros. That's not that expensive, okay? So a developer can get it from ST or from Renesas. Now, if you have the board, you just push a button and boom, you have your application running on your device, okay? So really, I encourage you to go to store.microej.com and download and try it out. And we will build the infrastructure. So right now, the online store is not there yet. It will come in the coming months, and then we'll have more cool stuff for application developers that will be announced throughout the coming months, and with big splash at CES in Las Vegas in January next year. Okay, so a few demo applications that just to give you an idea of what things you can run. You've seen some of those here, actually, and also to give you the size of the code and the resources. Those are the images, the fonts that are used to make those nice graphical UI. But you see, we're talking about kilobytes, right? That's really, really small, tiny applications. I'm sorry?
Of the virtual code.
Of the no, that's of the application. The size of the virtual machine, it's 30 KB. And then you have all the libraries necessary for running the applications. Then it's scalable depending on what services you need from your platform. But it's really tiny. Okay. Now, if you want to dive in more details about what you can find in the application platform, in the libraries. So this is more details about the base library. And actually, this table is written very small, but it's a huge list of all the API you can find. So what you have to remember is pretty much the application platform is a useful subset of Java 8 that is necessary for running Java applications that everyone is comfortable with. But what we have done is we've taken out things that are too big or not suitable for embedded space. And we have also added some other components, either that we wrote ourselves, like for example the GUI stack, because we didn't find anyone suitable and optimized enough. Those other components may come from Eclipse, like PAHO that you can find here, or Californium. Other stuff is coming from Android, like for example for interfacing with sensors and actuators. So it's really a mix of everything you can find what is best for running Java on embedded devices, right? Okay, so you will be able, I guess, to get the slides and get the reference there, so you can dive into more details into the API. I won't explain it one by one, but as you can see, that's very rich. A lot of stuff there. Okay, so resources, MicroEJ Studio free download on store.microej.com. If you are one of the software developers for building smart devices, then you can get the SDK. There's a free trial. It's also Eclipse-based environment, very similar to the Studio, but it comes with more stuff, and it comes with software that is suitable for production, for running on the hardware. We have also resources for developers at developer.microej.com, and also downloads. You can get application notes, you can get demos, you can get libraries. Some of the libraries are available in source and binary. You can get platforms, some example code. So there's the site developer.microej.com, and also some code on GitHub/MicroEJ. Okay. So as a summary, so Eclipse, very important for the IoT, a key contribution for making IoT possible, and especially connecting to the cloud side of IoT, providing really key open source ingredients and leading tools, languages, and libraries. But to enable this value and to get this value down to the IoT devices and hardware, you need this application platform provided by MicroEJ, really for those sub-gig small things that I was talking about. And MicroEJ, that's the new stuff. It's expanding to this multiple application environment and to this capability to provide application store and application download for your devices, and enabling developers to create applications with a free studio based on Eclipse, so you can build your ecosystem. Available at developermicroej.com, and again, more will come. We will be rolling out the full store infrastructure. We will be announcing cool stuff for developers in the coming weeks and coming months. Thank you, and I think we have 5 more minutes, 10 more minutes for questions, so for any comments you may have.
First question is debugging.
Debugging.
Yeah, how it is done.
Okay.
The Java code.
Yep. Well,
Is it still runs over the JTAG?
So
if you
JTAG. Okay.
So
Embedded. Okay.
So if you are debugging the
Well, first of all, you debug your Java code on the simulator on your PC with the Java debugger and everything.
if you want to debug on the real hardware, you still connect it to through JTAG, or you just use USB or?
it depends of the hardware. Some use